Great. Hi, good morning, good afternoon, good evening, wherever you are. Welcome to the Visualization Literacy panel. Our panelists here are some of the most famous people in the visualization literacy field, and I'm very excited to invite Katy Boerner, Robert Laramee, Lane Harrison, Elif Firat, and Kwon as panelists for the panel. My name is Alark Joshi, and I will be the panel moderator. I am an associate professor and department chair of computer science at the University of San Francisco. The outline for the panel is as follows. We will actually have position statements first from the panelists, after which we will actually have some discussions that I have some questions prepared for the panelists, but I will also take some questions from Discord and Slido. So feel free to keep posting questions there. And then there will be some provocations that have already been planned. So I'm excited to see where we go with that. So to kind of set the stage a little bit for the panel, we as a community have been discussing data visualization literacy for quite a long time. We've had panels at VIS, at EuroVis. There have been some fantastic papers in this field, many of them from the panelists, about trying to increase the visualization literacy of a group of individuals. But the root cause for the panel was, are we actually making a difference in the general community? Are we increasing the visualization literacy of audiences, general audiences? And then there's a subset of that is that, okay, what about professions that use data frequently? Are they using some of the cool visualization techniques that we are coming up with as a community? And if so, how do they use them? And if not, what are some of the barriers? And so here's just a quick list of what you'll gain if you hang out and attend our panel is that obviously you're going to learn from experts who have tested some of these things with general audiences and kind of discuss some of the barriers that they've faced when they do some of this research. And we also have a couple of panelists who are thinking about providing equitable access to visualization literacy. So we are not just conducting research in labs with college students and kind of making generalizable assumptions based on that. And then there's also a lot of new momentum about how do you validate these interventions that we design. So maybe you design some kind of intervention to increase literacy for tree maps, some of the work that Elif has done in the past. How do you validate that? And so there'll be lots of interesting avenues for discussion. So the order of the panelists is as follows. So we'll start with Lane Harrison from Worcester Polytechnic, and then Robert Laramee from the University of Nottingham will go next, then BC Kwon from IBM Research, and then Elif Firat from the University of Nottingham, followed by Katy Boerner from Indiana University. So with that, I'd like to pass on to Lane, and I'll mute my mic. Thank you, Lane.
All right, thanks. You have to stop sharing. There you go. I can't kick people off like I usually do. All right, thank you, everyone. I titled my talk toward equitable access to visualization literacy, and I quickly realized that that was a mistake because we are definitely not there, not close. So as I was putting this together, I had lots of thoughts about visualization literacy and how we might get there, the steps that we might take. But I'll just leave you with three thoughts. So, three thoughts about visualization literacy, equitable access, and the steps that we might take as a community to get there. I want to show it to you, though, and not just tell you what they are. So I want to kind of freshen you up first with an experiment. So I'm going to show you two scatter plots, left and right. Tell me which one is more correlated. How many say left? I'm checking Discord. Somebody does. How many say right? All right, congratulations, team left. You win. Left, it's not a trick question. R equals 1, R equals 0.95. So this is pretty straightforward. So I want to do this again, but I want to make it a little bit harder this time. And it's not a trick question. These are not the same. One of these is more correlated than another. Ready, go. How many say left? How many say right? Ooh, we're a little mixed there. So congratulations, team left. I'm so proud of you. You've got these visualization superpowers that we've been talking about this week. That's wonderful. Discord's funny. So they have the same difference, though. So I want to point this out. These have the same difference between them, but one is more correlated than another. Why is that? Or not more correlated, but one is harder to distinguish than another. And this is actually an old paper that we wrote like 7 years ago. And I don't really want to talk about the results of that paper right now. I want to talk about something weird that happened during the sort of setup to this experiment. So in this paper, we tested a lot of different chart types across different levels of correlation, both negative and positive. I want to hone in on this parallel coordinates plot, particularly the positive condition. So we collected about 200,000 judgments in a crowdsourced experiment, and different levels of performance. I want to focus here on parallel coordinates positive, and I call this the mysterious case of ETB. So ETB was a grad student in the lab who was helping me test this out. And I collected some initial pilot data from the experiment online with general population. And then I ran this by ETB. And it turned out ETB's performance was way better than everyone else on this odd visualization type. Like, we don't usually think about parallel coordinates. I mean, maybe we do for judging correlation, but especially positively correlated parallel coordinates with those parallel lines. It's a little bit tough to distinguish, but here, like, ETB's performance was much better. And these are fake results. Those are lost to time, but this sort of planted the thought in my head: to what extent might we differ in our ability to perform low-level visualization judgments? Second, could different performance be, potentially related to visualization literacy? I knew something about ETB. They know how to construct these charts at a low level. You can code them. Also very familiar with correlation. So maybe there's something going on here at a lower level. And then this kind of planted a practical seed in my mind. How might we measure and model these effects reliably? Well, I'm not a statistics expert, but fortunately, some folks in our community are. It turns out after we published this experiment and this data online, Matt Kay and Jeff Hare at VIS 2015 basically reanalyzed this data using hierarchical Bayesian modeling, and they came up with some better results. But one thing that stuck out in my mind was this line: we include a random intercept by estimating an offset UK from the intercept for each participant K. So this multi-level model allowed them to estimate basically, what might be ETB's performance against everyone else. And it turns out that these techniques, could allow you to actually measure individual visualization performance and compare them across groups, maybe even across cohorts. So this sort of stuck in my mind, and I, asked the question: with better models, can we maybe flip some of our visualization experiments in the community to study people instead of just visualization techniques? Even if you look at the results here, it's all focused on the visualization techniques, but maybe we can flip this to study people. So that leads me to my first thought. things pop up later. Wherever our visualization literacy journey takes us, better statistics and models might become a fundamental part of it. So as I've looked into this further, it turns out that these models apply across a range of tasks, not just for this one experiment, possibly multiple experiments, these very general techniques. Even some of these kind of like item response theory surveys that we might put out, spatial ability, literacy tests that have different items. You can use these modeling techniques across all of them. So that's the first thought. Better statistics and model might be essential to our journey in visualization literacy. So this got me thinking, how do we derive visualization guidelines and rankings in the first place? And a shout out to an award-winning paper here. So rethinking the ranks of visual channels, they're actually approaching this in a similar but very different way. So check that one out. All right, so if we think about rankings and guidelines of visualization, we might go all the way back to this classic experiment from Cleveland and McGill in 1984. Which of the two is larger, and what percentage is the smaller the larger? And this has been replicated many times. Here is Karen Bostock's 2010 paper, and then Cleveland McGill's original results on the top. And when I look at this these days, I'm thinking, like, are there potentially, ETBs hiding in all of our experiments? So, and it might not just be a super performer like ETB, there might be other meaningful patterns of performance. So what if we find people that actually buck trends of our typical rankings? So, we always hear that, you should use a stacked bar chart instead of a pie chart because position is better than angle. But what if we actually ran these experiments with these, better Bayesian statistical models and found that reliably some people perform better with pie charts in this case than the stacked bar chart. Or you might find other things. You might find, people are actually terrible with pie charts, but much, much better with bubble charts. This could be, sort of like a low-level bias. What I like about this Cleveland-McGill experiment is it's not just perceptual. People actually have to estimate ratios. So it might get into aspects of literacy that are, taught in school. And, for now, this kind of raises the question, if this is true, is low-level visualization task performance actually a skill? And if it is a skill, is it something that can be trained? So this took me to the K-12 curriculum here in the U.S. And, I was asking the question, where do these visualization tasks crop up in the K-12 curriculum? And I went to some colleagues in learning sciences, and they helped me find it. It's grade 6, so middle school, we study ratios and proportional relationships. So the next question I asked is, what kinds of visualizations are middle school students actually working with? So we looked at an online platform for learning in middle schools, and we found this. Unfortunate visualization of a pie chart here. It looks like somebody, just kind of pasted on the labels, and this is what your kids are learning with. Hopefully it varies. We haven't done a systematic analysis of it, but we can ask, can we do better? And I think the answer is yes. This is just a remake of that same chart using Vega Light. But whenever I see this, there are potentially possibilities here, like tools for generating good visualization problem sets for students. So what if we put some tools in the hands of K-12 teachers to better integrate good visualization practice in the K-12 curriculum? That might be nice. And we can also look at intervention studies and maybe even use some of these statistical models for randomized controlled trials in the K-12 curriculum, which is how learning scientists do it. So that took me a little bit further, and I just wanted to show another thing we're looking at now, which is exploring feedback. So is it, low-level visualization skill, can that be trained? So here's the Cleveland-McGill task with some animated feedback showing you how bad you were at judging pie charts. So that could be fun. Now for thought 2, I first want to take a step back. Experiments we've done in the past with older adults, so how big is the threat of my prostate cancer? We studied a visualization sort of mini system with older adults of varying educational backgrounds. And it turned out that the charts that we thought would work, these timeline visualizations, like here's your risk after treatment, they did not work at all. We actually had to end up using pie charts because that's what they were familiar with. So I think there's some possibly interesting implications there. And then there are also like really hard data visualization problems. If you've seen this mammography problem, like it's a brain teaser. It's very hard to think about. Lots of people get it wrong, but we found a correlate for spatial ability. And now I'm thinking about feedback and training and education. I wonder if there's always an opportunity, and maybe we have inadvertently laid a good foundation for the study and development of biz literacy through decades of our controlled experiments. So that's thought 2. And I'll be quick with thought 3. We might back up and say, like, oh, we're in a golden age of data viz. We've got all these, beautiful systems and data journalism and even visualizations for fun. Until reality sets in, recent COVID deaths, obviously this had something to do with data literacy. We haven't really sussed all that out yet. But my last thought here is, when we look at ourselves as a community, the visualization community, one thing that I've noticed is I just see a lot of empowerment of the creators and designers of visualization. And I wonder if we might, kind of challenge ourselves to also empower the individual. So my last thought is we must power the individual reading the visualization alongside our efforts to empower creators and designers of visualizations. That's all. Thanks to all my collaborators here at SF for the support, and I'll hand it over.
Great. Thank you, Lane. Our next panelist is Robert Laramee. Robert, take it away.
So can everybody see my slides?
Yes.
Great. So the title of this part of the presentation is called On the Death of Visualization Literacy. I chose this title because I thought it would be catchy and get everybody's attention. Let's see. So the title is, let me shrink this actually. The title is inspired by Bill Lawrenson's well-known paper called On the Death of Visualization. So in 2004, Bill Lawrenson published this paper on the death of visualization with the subtitle, Can It Survive Without Customers? And he was coming from a corporate standpoint, so he's working at General Electric at the time, and he was noticing that he was trying to promote more engagement between the visualization community and the corporations, basically. And he was also, there was an implied criticism in there that the visualization community was a little bit too inward facing. And this was also one of the inspiration behind the application papers that were promoted at the time. So in 2003, application papers went from 4-page short papers to 8-page full-length papers, and they used to have a separate review form as opposed to the research papers. And so I think of students as a special subset of customers, essentially. So instead of corporate-facing customers, we're trying to think about student-facing customers. They're not really necessarily customers, but they're an audience outside the visualization community where we're trying to promote visualization literacy. And so I was also thinking about what could be done and what are some actual things that we can do in order to promote visualization literacy, maybe inside the visualization, but especially outside the visualization community, and especially to students. So I'm going to share some thoughts on what could actually be done. One possibility, and probably several other people thought about this already, is introducing an education track or area to the Viz paper submissions. And it is kind of strange. I think it's safe to admit that it is strange that we're all teaching visualization, but we don't, and we all have this major challenge like, oh, I have to teach this class and I need all this material and it's very time consuming and it's very stressful, but we don't actually talk about it. We all have, this is the one thing we all have in common, but it's also a subject that we don't really talk about very much actually. This could be inspired by the Eurographics annual conference, which has an annual education, has an education track as part of its annual conference. 1 year ago, I also brought up this idea to the EuroVis organizers and the steering committee, the possibility of introducing an education track to the annual EuroVis conference. So that's a kind of baby step forward. Another possibility is a platform that shares teaching and literacy resources. So we have worked on something very closely related, which is the VIS Guides website. The VIS Guides website is a platform for teachers of visualization and students of visualization to share knowledge and especially cultivate guidelines. So if a student is not sure about the perfect color map choice for their visual design, they can actually post a question on VIS Guides and other people will answer it. The answers could come from other students, they could come from the teacher of their class, but it could also come from the teacher from a different visualization class or a researcher in the field. So it kind of opens up the classroom to a global setting rather than this confined little group of whatever, 20 or 30 students, the way it normally is. However, VIS Guides does not have any way to share like slides or teaching material per se. It wasn't designed for that purpose, but a platform that was designed for that purpose could be very useful in promoting visualization literacy. And another thought is possibly drawing from the literature that tries to promote computer science education in schools. So we know that there's a lot of existing literature that is trying to promote the concept of computer science education in schools in general, not necessarily visualization literacy. Visualization literacy is just a special case of computer science, really. And just like students are a special case of customers, so we can draw on that literature and look at the other initiatives out there that try to promote computer science in general education. Here's one example. Google is very interested. Google is very interested in this, so they have put together a free course that anybody can use to teach an introductory computer science class. So that's available for free. It's available for teachers and students to just sign up and start learning. Okay, and that's it for my point of view, and I think we'll save the questions for after everybody has finished talking. And thank you for listening, and thank you to Alark for organizing this. So let me see, how do I stop sharing? Okay, there we go.
Thanks, Bob. The questions are coming in on the Discord channel, so
okay.
Keep them coming. We will continue with our order, and BC, you are next.
All right. Okay, you can see my screen?
Yes.
All right, so the title of my talk is Towards Assessing and Training Visualization Abilities. I was just deeply inspired by the best paper given by Wesley Bullitt et al. On superheroes, so I just used some animated pictures here to inspire everything. So my talk is based on some prior studies on visualization literacy and education. So I built VLAT. It's basically 53 problem sets, so you can take multiple choice questions and then you get this literacy scores. We also developed a tutorial to learn how to read power coordinates and how to use it to solve problems. And then I did visualization studies with domain experts. So I also learned about how different users learn to use visualizations for solving different problems. And I also have taught several graduate level courses in the past. And this talk is basically reflection on all these activities that I did as visualization researchers and also instructors. Um, Learning visualization takes time. I think it's a journey process. So many people learn actually how to read visualizations, how to create visualizations by themselves, sometimes without much guidance. And so some people become very skillful at using visualizations gradually at some point. Unfortunately, some other people lose interest after trying hard. I really want to help the learners. I want to understand where they are stuck. How can we check where they are stuck? And is there a way to stop them? And how can we train them so that they become skillful as well? I thought about the learning process, and then I thought about how soccer players or sports players are being trained. So every player has its unique skill set, and then they have different skill levels. But as youth players, they're growing, and sometimes players not growing, then the team needs to properly assess the player status and then check on them. So the coach comes in and they probably use something like this, evaluation sheets, often have various attributes to evaluate, such as dribbling, ball controls, passing, and technical skills. And then as a remedy, based on the results, the coach builds a tailored training program to improve a particular skill that needs more improvements. And reflecting on how I do visualization teaching and also teaching users how to use visualization systems, I feel like I sometimes don't know what my users' skill levels in very much detail, like how coaches do their players. And sometimes I feel that my training program is not very individualized based on their status. And I think asking users or students to just play more games, and pick up your skills in the process may not be practical or effective because they might be just stuck and they don't know how to improve their skills. So I think I want to systematically assess their visualization abilities. So assessing ability skills for training. So what I want to achieve is, so maybe we can say player A is good or bad at soccer, but this statement or evaluation is too general, lacks focus for training purposes. Instead, we may want to assess their skill levels, so passing abilities, shooting abilities, defense abilities, and dribbling abilities. And what if we can do this for students or learners' visualization skills? Then my question is, do we know what are the visualization abilities? Can we measure them? And then finally, can we build the training programs to improve on those abilities? And then I brainstorm about those abilities and skills based on my experiences. So there will be a lot of different abilities. I just want to talk about something that I felt very important for students and learners to improve their visualization skill sets. These are just examples: encoding ability, decoding, visualization, shape recognition, shape insights, and so on and so forth. The first two items, I thought it's very important. So to understand visualization, I believe people need to learn how visualization encodes data using visual cues and how to extract data tables from a visual representation. So it's like going back and forth between data tables to visuals. Also at the same time, from visuals, if you can extract data tables from it, then you can, I think you can say you understand how visualizations work. So in coding ability, I built this tutorial in Kai paper to draw or sketch pair coordinates by themselves. We sometimes forget about this process because our software packages or tools just automatically do it for us. But by doing so, you can learn how data visualization encode data behind. Also, at the same time, we can also think about the backward process where you try to guess what the data set looks like that this particular visualization is visualizing. And I think Katy and Katy's paper also talks about this deconstruction process in the paper. The next topic was about how sometimes it's very challenging to pick out some particular visual features and locate the patterns and then associate them with some insights. So this particular New York Times article, I use it a lot to explain how Sankey diagrams work and how it could be useful. It talks about how people become congressmen or women by taking different career steps. So they actually locate, highlight very specific patterns and then talk about them. I think we can do these pattern recognition, we can improve the pattern recognition abilities by providing some more examples and maybe systemically organize a table of target patterns to look for in a visualization. So a lot of students and learners often ask me, what am I looking at? Where do I start? Can you tell me what's the shape looks like? So that's why I came up with this word shape. But so there are people who are wondering about where to start reading visualizations and what are the significant patterns they can extract out of the visualization. Another thing is about verbally stating those insights from the patterns. Last year, we've seen a lot of data visualizations on the web because of COVID, and this year as well with vaccinations. And there are great examples out there. For example, this BBC article just illustrates this line chart beautifully, that how you can explain certain patterns and how you can actually make statements and communicate them using language and visualizations at the same time. So could we do that? Could we actually train people on how to extract those patterns and then verbally stating? There might be other abilities. There are more and more thinking about question answering abilities, question posing abilities, interaction planning abilities. Once you know what you want to achieve, do you know how to get there by planning the interactions? So, concluding remarks, I want more people to enjoy data visualizations. I want to help people who are stuck in the process. And to increase visualization literacy, we may need more than a binary measure or a single score. May need to understand various visualization abilities and skills. We don't know yet, but maybe the next step will be to define abilities, skills, and measure them somehow. And then build a training program for those skill sets. And thank you so much.
Great, BC. Thank you very much. Our next presenter is Elif, but before she gets started, I just wanted to invite you all to post questions on Discord as well as the Slido. We will keep collecting questions and obviously have a discussion on Discord, but feel free to post questions. Go ahead, Elif.
Thank you, Alark. Everyone can see it, I believe.
Yes.
Yeah.
Okay.
Yeah. The audio is a bit choppy, Elif.
Oh, okay.
No, can't hear you anymore.
Oh, I think
now it works better. Yes.
Perfect.
Thank you.
So I'm Elif Firat from University of Nottingham, and I would like to talk about barriers to visualization literacy. As we know that visualization literacy is becoming more and more important with the increased use of visualization in many fields. However, it's a major challenge to identify barriers to comprehension of visual designs. So barriers that makes it difficult to understand visualization may be related to design components of visualization, which can be layout of space or data distribution, or presentation of visual designs such as layout, such as lack of labels or legends. So I think they show as a good example the pie charts, like as an example of not proper labels, or diverse backgrounds, people with different perceptual and cognitive backgrounds. So this can affect the interpretation of visual designs. So all these factors that can influence visualization literacy should be taken into consideration by educational and visualization communities. I would like to also talk about gender diversity in visualization. So most of the participants here, besides teaching visualization, data visualization, have something else in common. So many of you studied in 9 diverse classes and now teaching 9 diverse classes as well. So unfortunately, as many fields of science, females are underrepresented minorities in computer science related disciplines, which also means in visualization community. So as we all heard, like a lot of girls do well in maths and science, but what about their perception on computer science and stereotypes associated with typical computer science students? So they think that they should be extremely smart, or they should maybe have lack of social skills so they can understand programming, or they will be able to program in computer science course. So, but I believe that they don't know what the study of programming involves. So I believe they should gain an accurate information what computer science is, and they should get comfortable with coding and also grow some confidence in their abilities through the early education. So we also know that understanding of visual design is related to spatial abilities. So we can provide some evidence that males perform better at 3D spatial tasks than females. And there are some quotations from different papers that explain that as well. So what are the factors affecting this spatial ability in both gender? So we can say that factors can be the games they play when they were a child, for example, playing with Legos, or the books they read, or the activities they joined. And this is all playing a big role to improve their spatial skills when they were still a child. Luckily, there are some studies have been focused on increasing visualization literacy level of children. So as you can see, some of the images from those papers, they developed some tool to increase children's students' visualization literacy skills at primary schools, like at least using a playful manner to teach them how a visualization or how these tools are created or how it works. And also, not only for children, but also improving the literacy skills of general public is very important. Using interactive tool, educational tool to assist teaching and learning of a visual design by providing more active learning experiences are very helpful because they want to see the interaction, they want to see animation to understand the concept. For example, you published a paper on tree map with VIS last year in Eurographics. This image from the educational tree map tool we introduced in our paper. The tool was designed to teach tree map and provide an active learning experience as well as teaching tree map in a classroom using this animation. As you can see that there's a tree structure there and there's a tree map next to it. We show the correspondence between tree and tree map to explain the data hierarchy better using this tool. So thank you for listening. I think we will accept questions at the end.
Great, thank you, Elif.
Thank you.
That's great. Our next speaker is Katy Boerner. Katy, please go ahead. Katy, you're on mute. Okay, great.
Can you see my slides?
It's cropped off a little bit. Is it cropped for anyone else?
Can you see my slides?
Yeah, you might have to reshare. They're off the side of the screen.
Yeah.
Interesting. Okay, let me try this again. My computer seems very slow. Sorry for that. All right, let me try this again. Yeah, you would think after so many Zoom conferences you would have this perfectly set up, but not if it's no. All right.
We can just have Elif present again if something.
Can you see the slides now?
We see the presenter view, but we don't see the slides. It's kind of a...
Yeah,
Yes, very unusual. All right, it typically works. I'm really sorry for this. So let me just share the entire screen, and then I just have to make sure that nothing else is on that screen. That should totally work. Can you see the slides now?
Yes, perfect.
Wonderful technology, wonderful. Good morning, good afternoon, everybody. Sorry for the technical issues here. So it's very, very nice to be part of this panel. I've been deeply enjoying the discussions we had before we met all of you, but also the presentations today. And thanks so much, Alark, for bringing us all together. I think many of us care deeply about the ability of anyone to read and make or construct data visualizations. And it's interesting for me to understand how we can empower many, not just a few. And I think teaching teachers or bringing data visualizations into public spaces is one way of getting there. And what I wanted to do is to just quickly remind you that there are many, many papers that try to bring order into the way we can construct and define data visualization, with data visualizations and also data visualization literacy. In our world, we believe that data visualization literacy requires literacy itself, to read and write text, but also requires visual literacy, the ability to find and interpret, evaluate, use, and create images in visual media, but also, of course, mathematical literacy, to come from the data to the visualization, and also from the visualization back to the data. And BC just had great examples of that. And I truly believe that we need to empower everybody to not just be able to read and write and to do math, but also to render data into meaningful and actionable data visualizations. And some of you might remember the presentation I was able to give in 2019 in person in Vancouver, where we all got to get together in person, which was so much nicer than all these Zoom conferences. But in that presentation, we also presented the data visualization literacy typology and the workflow process. And if you move and combine both together, you have typology, a well-defined set of terms that everybody might agree upon, not necessarily all agree upon yet, but it's a first start to bring our community to an agreement on how to name certain insight needs and data scales and analysis and visualizations and graphic symbols and graphic variables and interactions, but also what process is involved from getting from a user need to a mathematically well-defined tasks that can be implemented in code, executed, and then brought back to human beings so that they can interpret it in real-world settings and do the second next action. And oftentimes the next action is to get more data or to zoom in somewhere or to ask a new question. And so by combining these two parts, you then have a way to not just have a process, acquire data, analyze data, visualize data, and then deploy it and interpret it. But you also know that visualization involves picking a visualization type, picking graphic symbol types, picking variable types, and then go over to deployment, which could be in a printout, could be on a handheld device, could be on a large display wall, or in VR, which also becomes now very affordable and feasible. In the courses that we teach, we have developed so-called make-a-VIS environments, which make it easy to read in data, to then select a visualization type, to select graphic symbol types, and to also select graphic variable types, and then to do this kind of visual encoding from the data to the visuals, seeing both at once, which I believe is very important to help people understand, oh, this data now is this kind of visual encoding, or this visual encoding I can convert back to the data. I think by having this both on a screen, we help new students understand how this all works. And then the other part that's also part of the framework is to really have a good understanding of what graphic symbol types exist, from geometric symbols to linguistic symbols to pictorial symbols, but also what graphic variable types are there. And some of them are qualitative, some of them are quantitative, and it's really important for students to understand it, for anyone. I think we are all still students and learn every single day, for everybody to understand that there are differences in how to use those effectively. And of course, these tables are very, very large, and they go over multiple pages, and some of these combinations have not yet been explored, and it will be nice to run more and more user studies. And I was especially pleased to see so many being interested in understanding truly informal and informal user studies, how that works for people. Now, in order to scale this, we implemented a certificate, a visual analytics certificate, which actually teaches this framework. It's a 6-week course, 30-hour commitment, which still is a lot if you take that away from your family time. But oftentimes you can do it in the evening or the weekend if we try to make it fun. And it's especially meant for busy people that have a full-time job already, but that still want to learn more of how to render data into actionable insights. And we have learned a lot by having different student cohorts go through. And we do learning analytics to understand what works, what doesn't work, what are the different types of learners that exist, and how can we best support them in a very individualized way. I really enjoyed BC mentioning that you really have to figure out where people get stuck and then try to help them there. Otherwise, keep them in flow, don't impact their flow, just have them have fun, But in some cases, they are either too fast, so they will run out of material and they will get bored with what we have in the course, or they are degrading very quickly because maybe they got sent on a business travel or they got busy with a deadline and now they missed important parts. And so we have to help them get into this flow state again. And so by running learning analytics on the back end, we can actually do this in a very efficient way. We also bring these data visualizations in science museums. This is a little difficult right now because many science museums were closed for a long time. They had to let go staff members, but many of them are back in business. They are open for visitors, maybe at reduced capacities. But you can then set up environments where people, for instance, can run or walk, and you can have them generate data this way and then explore their own data. And people are very, very interested in comparing themselves with others, especially famous athletes and others, or family members or peers. And you can then get them an incentive to compare themselves with different animals, or also have them try to figure out what is the impact of height and potentially shoes that people might be wearing on their speed. So here, time in seconds versus their height, and height also gets you a little bit of the age. So are the little people faster, or are the parents faster? And here also you get to explore scatter graphs, but you also get to explore different kinds of visual encoding because you can select different encodings for color, for shape, and size here on the right-hand side. You can also change axis labels in a very playful way. Ultimately, you can also do this for geomaps, and again, you can size and shape and color code your visualizations according to the data in the data tables that you can also always switch back and forth with. And you also have a legend in the lower right, so you get introduced to the utility of legends. Ultimately, it's very useful to make all of these study instruments available. We did this for a study in 2015, which looked at how science museum visitors can read or not read 20 common data visualizations. So you can go to this link and check out the study instruments. Ideally, those would be translated and run in different environments. In the US, it was rather devastating to see how low the data visualization literacy is. I hope it's better in Europe and Asia, but we have to run these studies, otherwise we might never know. I wanted to very briefly introduce you to other means to get good data visualizations and data visualization literacy to other experts, but also to many that would benefit from it. This is a project that creates a large knowledge graph for precision medicine. This is NSF funded and it's massive. It's a huge network and many will benefit. And the investigator team is shown here. But ultimately, you have a network of 3 million nodes and 30 million edges that has very important information about how, for instance, food items connect to diseases, connect to symptoms. And ideally, you would help anyone to understand this data better and to use it better for physician health, but also for personal health. And so now you have an interface where you can explore this meta graph, if you wish. And if you look, for instance, for coronary artery disease and connections to potatoes, if you are German, you might like to eat potatoes, and you get to see what kind of connections exist in that meta graph. But you also get to zoom into this graph, and it's rendered as a more geospatial map that more people can read. And you get to see the connection between potato via compounds to coronary artery disease. And you can zoom in and really get more information also on other food items and if they are good or bad for certain diseases. Another project that also has the potential to impact many lives is PubMed, the ambition to map the human body at single cell resolution, 37 trillion cells and counting, and this is funded out of NIH. The vision is to create a human atlas of the healthy human adult body at single cell resolution. There are many experts involved in this. As of last counting, it's 350 people now in this big science project. There are tissue generating centers, the data gets compiled, maps get created and get served to the world. And again, here, a major critical part is to create a common coordinate framework or a way to create an atlas. And an atlas is always a reference map with a way to map new data onto that atlas. And ideally, an atlas is authoritative, it's computable, it's published as part of the linked open data, it's open, and of course, it will be continuously evolving. So how do you do this, and how do you use data visualizations to help that all? And so we developed so-called AST+B tables, where you basically have a tree and then two bimodal maps that interlink cell types to this anatomical structure tree and biomarkers to cell types. And it's really hard to edit and to validate and to review these maps. And so right now we have these maps and references connected to 3D reference organs. And in order for people to actually deal with these large knowledge structures, now with 20,000 nodes and linkages, we developed this so-called AST+B reporter. And I think Alark posted links into the Discord, so you can explore that on your own. And you can now explore what we know about anatomical structures, cell types, and what biomarkers, proteins, genes, and others can be used to identify cell types. So this is a perfect way to introduce knowledge and data visualizations to a very, very large audience of pathologists and anatomists and surgeons, people which typically don't benefit from good data visualizations of the human body. We have a number of user interfaces, including ways to then zoom into a specific spatial area. And some of you might be familiar also with Neil Behrenbruch's work at Harvard University. So if you now click on these tissue sections and you now know what kind of anatomical structures and cell types are there, you can then go over to the test tissue viewer and explore that data in much more detail. There's an open MOOC that comes with all of this. So you're welcome to come in and learn more about HubNet. Again, there are many, many people involved in this. In the interest of time, let me stop with events and books that you might be interested in. There's a special issue coming forward on multi-level graph representations for big data and science. So if you work in this field, please consider submitting. There's also an upcoming conference next year, or actually in 2 years now, in 2023, on scientometrics and infometrics, the mapping of science that many of you might know us for. It's here at Indiana University, and we hope it's all in person by then. There's also the Atlas of Forecast that just came out, and there's another book very relevant for this panel, the Envisioning the Framework book. I just got a copy yesterday in my hand. So Jeanette Finch has done a marvelous job as an editor to bring together many librarians and others to introduce information literacy to many, and also many, many ways to evaluate it and to provide ways to increase information literacy. Thank you very much. I'm happy to answer questions.
Great, thank you very much, Katy. We have a couple of really interesting questions that I wanted to start with. The first one was by Mark, and I just wanted to, all the panelists feel free to turn on your videos. So Mark's question says that if education can help future generations to better understand and work with visualization and personalized training, so could personalized training help to increase visualization literacy for everyone? However, how can we make use of visualization literacy for situations where people either don't have time, are not interested, or don't have the opportunity to learn something new about visualizations? Can we adapt visualization in such a way that everyone can read and use and read visualizations at the current point of time? So, can you provide them some guidelines or while they are reading the chart? I'm happy to open it up to folks. Feel free to either raise your hand or just unmute yourself.
Well, I can at least say something, I think. I think that there's a growing trend with the wearable devices. So I think, for example, Apple is releasing some smartwatch that tracks your personal health, for example, and Amazon has a new wearable device and a new app that also tracks your personal health. And I think that the visualization literacy and personal health form a great combination and a great motivation to start engaging in the information literacy and the visualization literacy theme. And we're hoping to explore that theme here at the University of Nottingham, actually. But I think that with the rising popularity of the smartwatches and the personal health devices and wearable devices, I think that this is going to become more and more interesting to general audiences. And I think that this personal health theme is going to help promote visualization literacy, because I think these two are intricately associated with each other. And if you're trying to understand your own health and track your own health, you need visualization in order to understand your own behavior and your own, your health over time, health metrics.
Yeah.
So I can imagine that being an avenue for somebody that wants to learn passively some things about visualization and visualization literacy.
Sure. But, any other thoughts? I see Aim, you're unmuted. Am I calling on you just because you're unmuted?
Well, I was just being quiet, but the one thing that does come to mind, kind of to Mark's point. So I think of this as like, just-in-time training for a complex visualization. And, actually two thoughts. So one is with the rise of data journalism, especially over the past decade with things like D3, congrats on the award, you end up with news organizations like the New York Times trying to introduce more complex visualizations, but doing it in a staged way. And I feel like, some of the research done in the news community, maybe by BC and others, has actually sort of explored that explicitly. So I'm thinking of a particular example where they introduced a parallel coordinate plot by plotting each axis, sort of in turn. And then by the end, maybe you can actually, learn to work with a novel visualization that you haven't seen before. So this sort of staging and pacing, maybe. But again, the audience for the New York Times is not everyone. So I do want to keep that in mind, especially in the U.S. And then when we're thinking languages and cultures, there's still a lot of work to be done.
Yeah, I can't agree more. So I've seen a lot of examples. I remember John Guerra, one of the co-publicity of IEEE VIS, developed this squirrely telling explaining the Colombian election, and it goes from the core plot map to B-swarm plots toward the end. But since you start with a map that many people can understand, you can gradually turn that visualization into more complex ones so people can follow through. So I think there's a way to explain visualizations using some more basic visualizations, so more easier visualizations, and then gradually let them follow what it means and how to interpret them. Yeah, but for sure it requires more research, I think, how to do it better. But there are examples out there, I think.
And by the way, there was a paper on this very closely related topic, the cheat sheets paper, right, by Benjamin Bach et al. That would be a very nice avenue into this kind of just-in-time understanding of visualizations, I think. Just to bust out the cheat sheets whenever they're needed.
That's a great idea.
I wanted to add, I think, so Klaus Müller's group actually had this paper on learning visualization by analogy. I'm just going to post the link in the Discord channel, where they actually start with a chart that you may be familiar with and slowly transition to an unfamiliar chart. And I think that's an interesting way to look at it. And the cheat sheets paper is definitely an interesting, recent paper.
Yes, I was also thinking of that paper as well, Alark. So, yeah.
And there was another question, I think I'm going to try and pronounce it right. Chian Wen posts on Discord. As a person who has developed many complicated VA tools, I often find it difficult to teach the end users who are mainly domain experts and have little expertise in visualization. And I think many of us who've built that, that resonates with us quite a bit. My approach to something like that has been, if the training is worth the effort, like they will do it because that's going to make a huge impact in their regular workflow. But I think there's a lot that we can still do, and especially today's theme seems to be differentiated instruction based on where you are, what skills do you have, and can you actually make a difference and kind of augment the literacy that people are bringing to the table. But I'm open to hearing other approaches to how do you help domain experts.
I think this theme is very old.
Sorry, Bob. I think Katy's hand was up.
Oh, okay. Sorry. Go ahead.
Bob, you can go next. Sorry.
Bob, I want to hear your answer also. In our world, we work extremely closely with the subject matter domain experts, often rooming in with them, trying to understand their culture, their language, how they would use these interfaces in their environment. And oftentimes we have to say goodbye to what we thought we would be doing because we realize they need something completely different. However, oftentimes it's a combination of both types of expertise, the subject matter domain expertise, which really is needed to solve a certain problem, but then also our own visualization expertise to help them understand, wow, I could do this in a completely different, qualitatively new way. And then trying to see if that qualitatively new way works is non-trivial. For instance, with the AST+B tables, the reporter interface, where you have a tree and two bimodal networks. Very few people can read networks, so it's a challenge to actually get that in front of people. But given that these anatomical structures are well known to the anatomists, the cell types, many have their favorites, so they can just go alphabetically or otherwise find their favorite cell type, hover over it, see the connection to biomarkers and to anatomical structures, not only for their favorite organ, but across all organs, or right now we have 25 covered in the human body. I think that then gets them so much drawn into the data that the visualization basically disappears. It's only that they now get these new connections. They can then just reduce the visualization to those connections that they really care about. And then we are golden, basically, because it's much, much less complex as a visualization. And then if they can save out this data in a way that then feeds into other workflows they already have, then it's really a win-win on both sides. But it takes a while, and it takes a number of prototypes, and oftentimes you have to kill some of your darlings very quickly initially because it just don't work, especially if you want something qualitatively different. Over to Bob.
Yes, thank you, Katy. And you mentioned what I was thinking already, and that's one of the barriers to visualization and visualization literacy is the feedback loop that you have with the domain expert. So you have this, the starting out meeting. What are the questions that the domain expert is trying to answer, right? And that's like step one. And then you try to think of some visual designs that might help with answering those questions. But that feedback loop is basically too slow. Like it takes too long, and visualization is kind of too difficult. And it slows down the feedback loop. And you might have an answer or a prototype maybe 6 months later or a year later, right? And the domain expert has found a new job in the meantime. Like the world has changed. And I don't know if anybody remembers Jaak van Wyck's capstone. I don't remember which year it was, but he gave a capstone and he was showing the interaction between the visualization scientist and the domain expert, and he showed the feedback loop being very slow and the domain expert disappearing because 6 months had passed between the questions being posed and the solution being proposed. And I think this is a major barrier for the visualization as a field. like we need to think of ways to make it easier and develop maybe more rapid prototypes and make the feedback loop faster and the iterations between the domain expert and the visualization scientist tighter and more quick. Yeah.
I think if you start with hand sketches and with interactive prototypes and you do run user studies for those before you get this to any kind of programmer, that actually gets you a much, much faster way to explore different options. And then you also get the buy-in from the domain experts faster. And then the programmers, they are also pretty happy because they have to spec out evaluated, optimized specification of what really needs to be implemented. They don't have to invent that anymore. They get the spec, they implement it, and then you got exactly what's in that spec, maybe with minor changes. But I think this kind of workflow, of course, requires quite a bit of resources, and so you have to pick bigger projects which have a longer lifetime. And I do agree, if you want to implement this in real connected to big data, it is a half a year for the first prototype. And then after that, you want to optimize this and grow it and productize it. So that's even longer. So in some cases, some of us are lucky enough to have these big projects. But in other cases, it's much smaller projects where you have only 3 months to do something major. And then libraries come into play. And there are now a number of really neat visualization libraries that you can readily use to feed in your data and get a prototype within a week or two.
Great, thank you. Thanks very much, folks, about this insight into domain experts. That's a very challenging aspect of working in application field specifically. I wanted to kind of switch gears a little bit and come back to maybe like visualization for general audiences. And I had a quick question for Lane about teaching diverse users to read charts. You had a paper earlier about potential biases and how we can actually use that to improve visualization literacy. The paper kind of talked almost of like unifying themes with cognitive biases and visualization literacy. I was wondering if you've had any more new thoughts about that.
Yeah, I mean, to be honest, when you start to look at biases and measuring the biases, that turns out to be a very hard problem. So personally, I've kind of taken a step back and gone down to even lower level things where we might find differences across people, and then maybe interventions at that level. But maybe the question is like, if we can make people aware of biases, is this actually going to help them? And I think that might be true, but I don't know if you need to be aware of a bias to actually perform in like an optimal or performant way. So I think the jury's still out. We need to run studies, and we need better measurement tools. I think that's a thought that I keep coming back to. A lot of visualization studies are around, let's average everyone together and get some sort of confidence interval on it. But we can, with newer methodologies, we can go beyond that. And I think that's, especially when we're talking about literacy, different cohorts, different languages, different cultures, we probably need to up our game in that department.
Great, thank you. So I've been quite interested in just the visualization literacy assessment test. So BC, this question is coming towards you. Do you feel like since you published the paper, do we need to revisit any aspects of it, or maybe, just please go ahead and tell us more.
Yeah, just to give you some background history, so we published the paper in 2017, and then it took 1 year for us to publish the website of VLAT. We should have done it sooner. I didn't get any emails from anybody for that 1 year gap. But after we published it, all of a sudden, I received so many requests from many people outside my network, permission to reprint VLADs, sometimes in other languages. I've seen Korean, Czech, German. There were Dutch primary school teachers who wanted to translate it. I don't know if they did it. Also, some folks asking, can I use this as part of the training workshop program for companies, accountants, K-12 students, and many more? Also use this survey as part of their dissertation thesis and many more. So what I'm thinking right now is I'm fully on board with Bob's idea about sharing the resources together and amplify the effects, because a lot of people are actually need this, I think. They are searching for resources, and they luckily ended up went on my webpage and then asked for some help because I put my email address there. So I got a lot of emails about this VLETs. We did another study follow-up to test the correlation between VLET scores and other types of cognition, like need for cognition and numeracy and so on. We find some positive correlation there. So I'm curious if there, I think there needs to be some empirical studies on what kind of mathematical skills or abilities or inherent traits or some environments are associated with the abilities of learning the visualizations. And another thing that I'm interested in, but is recently a lot of people talk about this ethics of data visualizations. And my worry is that general audience starts consuming a lot of visualization through news media because of COVID. And then sometimes there are visualizations that could bias people. And I wonder if people have enough knowledge to really understand there could be a bias in this type of visualization because of their design issues. So maybe there could be a test or could be a tutorial on how we can help out. There are some issues like this, and you can avoid falling into a trap, something like that. That's what I've been thinking about.
Great, thank you. Because I think VLAT is comprehensive and great, but I feel like having that as a pre-test or a post-test is a little difficult because it in itself takes a lot of time. But that's very useful. Thank you. So, kind of bringing back to the K-12 discussion that Lane started, and then Bob also mentioned a little bit of. We have a question on Slido which says, if this is a K-12 education problem, how can we get in touch with the teachers, or shouldn't we take care that they understand our VIS first? And I'm very curious to hear what you have to say. Go ahead, Lane.
Sure. I haven't actually run a study with teachers on these low-level visualization tasks. That's a great idea. I am running a study right now with K-12 teachers on sort of a complex visualization system, and that's actually been really useful to see like how a range of K-12 teachers are making sense of like a typical visual analytics system. So I think there's some room to be done there. But teachers, from what I can tell, they're very into ongoing training development. Sometimes, at least in the U.S., it's mandated by the state or the district that the teachers are in to sort of up their game and learn new material that they can integrate to the classroom to be better. And just from talking to colleagues in learning sciences that run these platforms that thousands of teachers interact with, one thing that I know for sure, I've heard several times now, is that data science, for whatever reason, is a very popular topic. And now that extends beyond visualization itself, but there may be a nice opportunity window here for the community to capitalize on that and make those connections. And I think we could potentially see some impact.
Great. I want to mention that Fanny Chevalier's group has done some work in visualization literacy at elementary school level, and I posted links to their papers in there. They built an app that taught students at the kindergarten and second grade level actually how to read visualizations, which start in a very unstructured form but eventually get to something like a bar chart. But I think I completely agree. I think we need tools that even teachers can use in the classroom, similar to what Fanny's group has developed. Elif, I have a question for you, which is, you talked about reaching diverse audiences, and I was wondering, how can we reach more diverse audiences to try and kind of help them read and interpret charts accurately. We briefly talked about diverse skills and abilities, but we didn't really touch on with whether gender differences, or even something that's more popular along the same lines is older audiences, like older adults on smartphones or websites. How do they analyze and visualize charts? So do you have any thoughts about that?
Yeah, thank you for the question. So I believe that online tutorials are getting popular with the pandemic. So everything is online, and I think the old people as well, they're more interested in learning different stuff. So I think if we can reach them with an online tutorial or online course, or even if they're able to go to attend a workshop, so I think we can organize some workshop so they can join and learn how to read and understand the visualization and see the hidden message provided in the visualization. I'm sure that will help them to understand the pattern and the trend in the data. So even they will help them to make some decisions instead of relying on someone else's interpretation. So they can, as I said, they can join the workshops and join some online tutorials. That can be good approaches, I think, for the general audience.
Yeah, if anyone has any insight on that, please feel free to jump in. I feel like the theme is differentiated learning, but I think this idea of bringing your own data to a workshop and actually, really giving them an immersive experience of, this is what you can learn about your own data. That's really fascinating. And I think that can kind of at least open their eyes about the possibilities of what you can get by using data visualization. There is another question here by Mark. It says, we shortly spoke about a feedback loop, since visualization literacy is not only about reading and understanding, but also about authoring and configuring. How should a training or a guide, how should it look like for such systems? And how can the simple process of creating visualizations by our own already increase visualization literacy? Any thoughts about that?
I can say something about this.
Yeah, go ahead.
Yeah, and I think it's also very popular that people provide some web-based tools online. So if you have a data or a spreadsheet, you just basically upload there and create a visual design. But before that, they should be able to understand, or they should have a question at the beginning, what they want to see on a visual design. And after that, they will decide what kind of visual design they need, either this hierarchical, either they want to show a hierarchical data or a multidimensional data. After making decision what kind of tool they need, they can basically use web tools to create their own visualizations.
There's another way of doing it, Elif. So one is that they have a question and they want an answer. That's good. But another way is to have them go into a public space, a museum, a library, an office space, and just see something cool, and then get drawn to it, and then realize, oh my God, I could actually put my own data in here and compare myself with the other data that already exists, be it the census or other kind of data visualization. And I think this way they would get to see themselves in the data, in the context of other data, and they would get to play with it. And I think it has to be playful. And then ideally, they can get different perspectives, right, of that data. And they get to understand, oh, well, I can now have a geomap or a scatter plot or some other network visualization. And it's all in that data. And this is the raw data. It's the table. This is the new visualization. And this is how the mapping works from the data to the visualization. And then start with very simple visualization. Level them up, help them understand that a table has columns and rows, and a scatter plot has two axes, and a world map has latitude and longitude, and even a network visualization also has two dimensions, even though the nodes are laid out in a way that you can mirror and rotate them. But it's always understanding the reference system, and then also understanding how you can add new data to it. And I think as long as these kind of basic elements are clear, they can go a long way alone and have a lot of fun with data.
So related to that, though, is with this access to K-12 teachers, Katy, I have a question for you then. Like, firstly, how did you get permission to conduct those experiments with the museums? And how easy or difficult was it to get permission? I mean, how many people did you have to talk to, and how long did it take?
Most science museums, and we worked very closely with the Science Museum, in actually 5 different science museums, too many to list here, but it's funded by the National Science Foundation. It's a so-called AISL program that cares deeply about informal science education. And there are many, many which get funded from that type of money, and then they get to work out of the academic setting with science museums that oftentimes have an evaluation team already on the floor, and they know when it's good to run these evaluations, and they also know about the rules and regulations that exist in these different museums. And then it's our team creating stimuli in close collaboration with these science museums, because it has to be relevant to the exercises and engagement activities that exist on the floor, and then analyze the data together to ultimately make sure that this is not just a fun time, a fun date, a fun outing with a family, but people really take some new insights and some actionable insights away. So I think it's a win-win on both sides. We get access to a lot of data because there are many, many people in science museums which are not just computer science undergrads. And we also get access to that rich expertise that exists in science museums of how to engage people, how to communicate science to many. And it should be just done way more often. Same for the library system. Many libraries have outreach coordinators, and they are interested in events like this. And you can always ask your local library, could I have an event? I would love to get some data. And in fact, many of our public-facing mapping science exhibit prototypes, we first test in our local library, because that's closest to the audience we will have in other venues. We do not test them here on the IU ground because we have a very different population here.
Mm-hmm.
One idea maybe I can pitch in to engage with the K-12 students or teachers. So my wife is a K-12 teacher, so she's teaching at a primary school. And before COVID, they always wanted to find a place to visit as a field trip. And Boston has a lot of science museums, and even they visit university labs and institutions. If university labs can provide some visualization experiences and then provide some programs for those primary school students and teachers, maybe there's a starting point to make connections and start building a project from it.
That's a great idea. A lot of universities actually have like a visit a university day where you end up having some kind of a science project. And I think that ties in with Maria's question, whether are there good resources for introducing VIS to elementary school teachers, students, parents, and maybe examples of possible science fair projects for K-12 students. And I'm very curious to hear more about that.
Can I draw a distinction here? So I want to go back to something that Mark said and sort of a theme. And I just want to make sure that we prioritize correctly. So we're talking about just-in-time training. We're talking about kids who get to go to museums and to universities. That's something that I think a lot of children might not ever get to experience. So when we're thinking about this, I'm always drawn to playing the long game. So how can, the next pandemic in 30 years, how can we be better prepared? So I think, all these ideas are great and we should definitely do them, but we should also think about what are the long-term impacts of maybe reshaping the curriculum. I'm struck by seeing that the Common Core has circle graphs, as they call them, as part of it. I don't know how that was formed. I don't think that anybody in the visualization community had any input. And that's just in the U.S. alone. So When we're thinking about these cool ideas, getting students around a touch table, like I used to do when I was a grad student, versus maybe impacting the curriculum at a very broad scale. I think we need to think about both opportunities there, because one's going to hook them, and then one's going to teach them those skills and maybe turn them into different consumers of visualization than they otherwise would be.
I completely agree. I mean, we actually worked with some middle school teachers to teach them how to code and give them lessons and lesson plans so that that could reach their students. If you hold a coding camp, students are going to self-select and attend, and those students are not the ones who maybe, they would get that access anyway. But if you actually produce material and work with teachers and train them, they will end up teaching the entire classroom, not the students who are self-selecting. I think we are going to run out of time in a minute, but I'm excited to hear any closing thoughts that people have. Maybe we'll go in the same order. Lane, do you want to go ahead?
Oh gosh, I don't have closing thoughts. I just have that continuation of a thought. There's a paper at Kai last year from Crystal Lee and Arvind Satyanarayan and others talking about these COVID visualizations and the fact that some people had high visualization literacy, high data literacy, but they were saying things like vaccines don't work, masks don't work, using the exact same visualizations. And I think about that all the time, as someone who grew up in sort of that type of bubble, anti-vax, how do you break out of that? And when we think about empowering the individual, at least for myself, that's how I feel that I did. I was like, oh no, you're saying something, but I can read the data and I know that you're lying. I think is a really potentially powerful and transformative thought. So when we're thinking about the top down, know that it can be misused. If you think about the bottom up, it's the same way. But I think a balance of power is something that we need to consider whenever we think about visualization literacy long term.
Great, thank you. Bob, you want to say anything quickly?
This is not really the world's best closing statement, but I wish that the web-based visualizations were easier. I know a lot of people will say, well, they're very easy, but I think we underestimate how difficult the web-based visualizations, and two kind of pieces of evidence that I have for this are Many Eyes. I think we all wish that Many Eyes was still around, but it's not. It's died. And the same with the money map of the market. So that was a great IBM visualization, web-based visualization of the market, and that's gone too. So the web, we sort of underestimate how difficult these web-based visualizations are for general audiences. And it would be great, as much as we would like to have more of those, it would be also interesting to figure out how to make them, give them a longer lifespan, essentially. That's my closing remarks.
I didn't prepare for closing remarks, but I want to see more VLETs, different variations of VLETs from the community. The reason why I talked about different abilities, I want to know better about our audiences, our users, students, where they are stuck. And I think there could be better ways to assess and help them really learn the visualizations. And I'm inspired by the talks that we did today, the conversations. Just-in-time training. I think that's something, the avenues that we need to really look out for, like how to understand the general audiences better. There might be a way to engage with the audiences by using some tools or by just observing how people interact with the tools. And I would love to see more work to be done in this process. Yeah.
Thanks, Elif. You want to go quickly?
Yes. I would like to. Yeah, I will keep it short. So I would like to say that before finishing, changing the perceptions of gender inequality and the abilities of women are it should change definitely, because any woman like any age, it can understand and create visual designs. Like they just need to practice and, I don't know, break the stereotypes in their minds. And also, we should investigate barriers to visual designs in terms of like maybe design components. Like we should explain every detail properly. And but the last one is we should focus more on developing tools, because we need that. We need to show like animation and interaction rather than teaching visual design using 3D slides. 2D images on slides. I think these are extremely important to increase the visualization literacy.
Thank you, Katy.
Alark, thanks for bringing us all together. I think this has to be a continued organization and discussion, because we have to do a lot of work. And I think it's us experts which would bring together the means, the computational means, the algorithmic means, the data means, and the frameworks and methods and processes to really empower anyone to read and make data visualizations. It has to be us. There's nobody else we can just point the finger to. So I think we all have to agree on how to define data visualization literacy, how to teach it, how to measure it, how to optimize it. And I really, really hope that there will be future panels like this. And I would be happy to be involved and engaged because it's near and dear to my heart. I think this is a huge duty we have towards anyone to help them not do just their mathematics and their reading and writing, but they absolutely must have a way to deal with all that data that is now in existence in their lives. So thanks again, Alark, and everybody. I really enjoyed your presentations and look forward to communicate in the future and collaborate maybe.
Yeah. Well, I guess I'll close out by saying thank you very much, everyone. Thank you, panelists and attendees, for all the questions. And the answer for can we make a difference is yes, I guess. We can make a difference. We can work with K-12 teachers and help build tools for them. We can kind of think of interventions that meet people where they are rather than trying to pick a one-size-fits-all approach. And I'm very optimistic of the future of visualization literacy. So I guess we'll leave it there, and thanks everyone for attending.
Thank you.
Thank you.
Thank you, everyone.
Thanks.
Thank you. Bye.
Thank you.
Perfect. I've switched off my